For this video, I'm going to be assuming that you know how F2L of the Friedrich system works. Like, instead of inserting one edge piece and one corner piece at a time, you would insert them both at the same time. And for partial edge control, you'll have to be able to quickly identify things called bad or good edges. What a good or bad edge is a good edge is when you can align an edge piece with its center using only the up or right face. Like this is a good edge because I can align it like that. This is a bad edge because I can't align it with its center using only the up and right faces. See how I can't? Same thing with this edge. I can't align it with this center. Even though I can align it with this, I'm not paying attention to that because I'm only focusing on the right and up face. So this is a bad edge because I can't align orange to orange. Even though I can align green to green, I'm only focusing on the up and right face. This is another good edge because I can align it with its center like that. So that's pretty much what good edges and bad edges are. In partial edge control, what we're doing is we're trying to orient as many or all of the edge pieces on the last layer as we can. And this revolves around the fact that if you only use two sides to scramble the cube, for example, the up and the right face like I just did, when you solve these two F2O pairs, if you only use the up and right face, then this cross will already be oriented. So you cannot disorient or orient a edge piece using only two of the sides. And in partial edge control, we're focusing on the up and right side. Now say we had a case like these. These are exactly the same scramble. I've already completed 3 of the F2L pairs, and we're getting to the last one. All of these edges are good edges because these are all oriented. This can be aligned with its center there on the right side, and this can be aligned with its center right there. So this piece has to be paired up with this piece and then inserted in there. So to do that, you might do something like this. I inserted that. And we used to have 4 good edges, but now we only have 2. That's because we used the front side. If we only used the right and up side, we'd still have all of the good edges. So if we did something like this, only using the right and up side, we would have all the cross, and we'd have an easy OLL case. So whenever all of the edges are good edges, you can use the up and right face to keep them oriented and insert this. If you can't insert this, that means that not all of the edges are good. Now let's say you had some cases like this. These are exactly the same. Okay, so all of the edges are bad edges except for the edge that you're inserting. And so the easiest way to insert this is like this. U, R, U prime, R prime. See how that's inserted? Well look, we have this case where none of the edge pieces are oriented, and then when you have to do whatever you do, you might do something like this. Where first you get the line, and then you get the cross. Which that would take away from your time. But if you did this insert instead, R prime, F, R, F prime, then you already have 2 of the edges oriented. So if all of the edges are unoriented and you are inserting a piece, use a third side to orient a piece. So what you're doing is whenever you don't want the pieces to change their orientation, you only use two sides. But when you want a piece to change its orientation, you use a third side, and that's what this was, that insert. Instead of this insert, it was this insert. It used the F face. So that's pretty much it for partial edge control. Basically what you're doing is using the property that the two-side property that edges can't be disoriented using only two of the sides, and use that to your advantage to keep pieces oriented or to orient pieces that aren't oriented. So thank you for watching. If you have any questions, feel free to message me and I'll be happy to answer them. Bye.